Hello, this is Mrs. Arnold, and in this video, we will talk about relative age dating. Questions you should be able to answer at the end of this lesson are: what geologic principles are used to interpret rock sequences and determine relative ages? What are the different types of unconformities and how do they differ? How do scientists use correlation to understand the history of a region? The main idea of this video is that scientists use geologic principles to learn the sequence in which geologic events occur. In the 18th and 19th centuries, there were two ideas which scientists debated. These ideas were catastrophicism and uniformitarianism. The idea of catastrophicism is that the Earth's surface is the result of catastrophes, things like asteroids striking the Earth or volcanic eruptions. So this idea is that all geologic change occurs suddenly, and it is a rationalization for a biblical age of Earth, which the belief there is that the Earth is only a few thousand years old. On the other hand, the other side of debate was uniformitarianism. So this is the idea that the Earth's surface was the result of gradual changes. By the end of the 19th century, the idea of uniformitarianism was accepted and embraced by scientists. These days, we know that both principles apply. What that means is that most of our features on the Earth can be explained through uniformitarianism, but some features can still be formed by catastrophes like earthquakes, landslides, floods, volcanic eruptions, and asteroid impacts. So what we have here is that most change is gradual, but some catastrophic events that changes the surface of the Earth do occur. Okay. So James Hutton is the geologist behind the idea of uniformitarianism. And what really got him thinking about this is the picture here. So this is Sycamore Point, which is near his home. And what I'm about to read for you is a little excerpt from the Geological Society of UK website. So the Sycamore Point unconformity is also known as Hutton's unconformity. It is an internationally famous place of geological pilgrimage. It is of great historical importance to the development of the science of geology. So the cool thing about Sycamore Point is that we have nearly vertical sedimentary rocks of Silurian age that are covered unconformably by younger rocks, which is very unusual. It's unusual that these older rocks are vertical, and it's also unusual that they will be covered by older rocks. So when James Hutton solved this, he knew that these unconformities could not have been created through a catastrophe, that these things came about very slowly over a very long period of time. So this helped introduce the idea of the enormity of geologic time and also the integrity of planet Earth. So as I mentioned, James Hutton was a Scottish geologist. He's one of the first people to think of the Earth as old. He wrote The Theory of Earth in 1788. And basically, he argues that geologic forces like erosion operate over long stretches of time. And this is going to be the foundation of uniformitarianism. So basically, he went to Sycamore Point and he saw these different geological features, and he saw like deposition happening and being deposition happening and those rocks that had been eroded being carried away and deposited somewhere else. And he hypothesized that over time that will form a landform, and also that many of the landforms that we see must be formed over time. That's just another example of something that he saw there at Sycamore Point. Uniformitarianism states that geologic processes occurring today have been occurring since Earth formed. An example, the waves crashing on a shore in the Jurassic period were much like the waves crashing on shore today. This is the idea that the present is the key to the past. We can use what we know about fossils and Earth systems today to help us interpret the past, because these same forces, erosion, weathering, have been at work and working the same way since the beginning. Relative age dating is one way scientists learn about the past. They do that by studying the order of geologic events that occur. If you were sorting through a box of family photos, you might not know the exact date that each picture was taken, but you could use clues to put them in chronological order. That is what scientists do with rock formations. They look at how the rocks are arranged relative to each other, and then they can infer the order in which they've formed. There are principles for determining relative age. These are original horizontality, superposition, cross-cutting relationships, and inclusions. So original horizontality is the idea that when rocks are deposited, when sedimentary rocks are deposited in particular, they are deposited in layers. Okay. So these rocks here are representing the layers of the Grand Canyon. So the horizontal layers of the Grand Canyon were formed by deposition of sediment over millions of years. The principle of original horizontality also states that the tilted strata that we see here at the bottom were first formed horizontally. So any tilting occurs after the layers were laid down. So they weren't formed at a tip. They were formed and then something else happened that made them tilt. The law of superposition is saying that in an undisturbed rock sequence, the Otis rocks are at the bottom. So this was not the case at Sycamore Point. This is how James Hutton knew that something really weird was going on, because the younger rocks were on top of the old rocks. But superposition, I'm just going to draw a few layers here. Superposition is saying that this layer of rock is the Otis, in this layer of rock will be the youngest. So each consecutive layer is younger than the rock layer beneath it. Cross-cutting relationships. This principle states that an intrusion is younger than the rock it cuts across. This also applies to faults. And you might be wondering what an intrusion is. An intrusion is rocks that form when magma pushes between rock layers and solidifies in existing rocks. We can see the intrusion happening right here in this picture. So this is the magma that came and cut into the rock layers that were already there. Okay, so whenever you see intrusion, you know that the intrusion is younger than the rock layers that it cut across. And inclusion, this principle states that fragments, which are called inclusions, are older. Actually, let me restate that. Fragments in a rock layer are older than the rock layer that contains them. Sometimes the record of a past event or time period is completely missing. For example, if rocks from a volcanic eruption erode, the record of that eruption is lost. If an eroded area is then covered at a later time by a new layer of sediment, the eroded surface represents a gap in the rock record, which we call an unconformity. There are 3 different types of unconformities that we will be looking at. The first unconformity is a disconformity. This is when a horizontal layer of sedimentary rock overlies another horizontal layer of sedimentary rock. after a period of erosion. The next unconformity is a nonconformity, and this is when a layer of sedimentary rock overlies a layer of igneous or metamorphic rock. In this case, the eroded surface is called a nonconformity. The next unconformity is angular unconformity, which I think is the coolest because I think it looks the coolest. This is when we have the tilted layers of sedimentary rock that are underneath horizontal layers. So how does this happen? So we have horizontal layers of sedimentary rock are usually uplifted during mountain building, which exposes them to weathering or erosion. If horizontal layers are later laid on top of them, like how they are in this picture. So if horizontal layers is later laid down on top of the tilted layers, let's say tilted eroded layers, the resulting so once again, angular unconformity is when we have tilted strata and then horizontal strata on top of them. And you can kind of get a sense of the scale of these tilted layers because this right here is a person. Correlation is the matching of unique rock outcrops or fossils exposed in one graphic region to similar outcrops exposed in other graphic regions. We can do correlation using rock layers. The Kaibab limestone layer rims the top of the Grand Canyon in Arizona, but it's also found more than 100 kilometers away at the bottom of Zion National Park in Utah. So geologists know that these layers formed at the same time through correlation. This is known as the Grand Staircase. So with the Grand Staircase, the top layers of rocks at the Grand Canyon are identical to the bottom layers at Zion National Park, and the top layers at Zion National Park are the same as the bottom layers at Bryce Canyon. And we can see the dates of when these layers formed, the eons in which they formed, or should I say eras, actually. We can also correlate using fossils. Correlating fossils from rock layers in one location to rock layers in another location shows that the layers were deposited during roughly the same time period, even though the layers are of different material. If we look at this fossil, we can see that it is in two different locations. And those different locations have different sediments. But since the fossil is found within this particular layer, we know that these two layers in different locations with different sediments are roughly of the same age because they have the same fossil. Today, we learned how relative age dating can be used to sequence geologic events. Please make sure to have your notes with you for the quiz in class. Have a wonderful day and be kind to one another.